All right, good afternoon. My name is Michael Conrad. I'm the product unit manager for Microsoft Office Live Meeting. On stage with me today is John Shriver-Blake. He's a program manager in my team, and he'll be walking us through each of the demos that we're going to show you today of a prototype conferencing service that we built using the Windows Azure platform. So a little bit about myself. I've been at Microsoft about 12 years, the last 6 of which I worked in the live meeting, Office Live Meeting team. And so I've been there since 2003, since the Placeware.com acquisition. The presentation today is primarily focused on our investigation of the Windows Azure platform and building a next generation conferencing service using it. So today we'll give a brief overview of the live meeting service for those of you that aren't familiar with it. Then we'll introduce you to a proof of concept service that we built on the Windows Azure platform. We'll be focusing on the Windows Azure aspects of deployment management, using the Windows Azure Compute Fabric, and using the Windows Azure storage. And if there's time in the end, we'll take some questions. So Live Meeting is an enterprise-class web conferencing solution for online meetings, trainings, and events. It is a real-time communication solution. And we support the modalities of audio and video, screen sharing, and PowerPoint. And our meetings or events can have from a few attendees up to thousands. Our service usage, we have about 10 million meetings and about 5 billion minutes annually is our current run rate. We are growing in usage year over year. We have about 10,000 customers total, and that includes a lot of Fortune 500 and telecommunications companies. We are a global solution, so we have data centers around the world, 4 of them, with about 1,600 servers deployed in those data centers. So giving a real basic overview of the live meeting architecture today, you can see there's different layers. The top layer is the actual live meeting application. Up here is where the piece that we focus on, that the customers see, that brings the end value to the customers. The lower half, the custom infrastructure piece, is infrastructure that we built in live meeting to support the application that we want to get in front of customers. Just some basic things. We manage our own identity, our own user management, billing, etc. And then from a foundational perspective, we have our own deployment mechanisms, monitoring and storage, etc. So we spend a lot of time, money, and resources in this custom infrastructure. And that, of course, takes away all those resources from the actual application that we want to get in front of customers. With Windows Azure, the architecture of the prototype that you're going to see today, you can see that the top layer is the same. It's the same application that we want to deliver to customers, the same value. But what we've done is built on top of the Azure Services Platform. And by doing that, you can see that we remove a lot of the burden of building this infrastructure from my team, from the live meeting team, and we just rely on the Azure Services Platform. It's actually a great win because none of that custom infrastructure that I talked about in the previous slide, none of it's reusable to any other service at Microsoft, certainly not to third-party developers. It's custom for live meeting and doesn't move well. So now John is going to walk us through the first demo, which is the prototype of a live meeting prototype on Windows Azure. John, right here.
Thanks. All right. Thanks. Ooh. All right. Got it? Good. Thanks, Mike. So as Mike mentioned, for the past several months, we've been building a prototype of core live meeting functionality running on Windows Azure. And we went through this exercise to help us understand the features and capabilities that Windows Azure has to offer, and also to start building our experience on the platform. Throughout today, I'm going to be showing you a couple different aspects of that prototype running in our and we're actually going to start today by cutting straight to the chase and looking at some of the core end-user in-meeting functionality that we've implemented in that prototype. We're going to actually start this demonstration with what you see here, which is a standard live meeting session. I'm actually connected in with some of my colleagues back in Redmond, and hopefully, if all goes well, we'll be able to talk to them. Guys, can you hear us? Hello?
Hey.
Hey, speak up. Hello?
How are you?
Good. How are you? How's the weather back there?
Pretty good.
Pretty good? It's been 85 and sunny all week. You guys really should have made the trip. Anyway, thanks for participating today. I'm going to go ahead and mute you, but you'll be able to stick around because we'll be watching you. So this is a standard live meeting session running against our standard service today. And you can see we've got the audio video running. We've got the PowerPoint presentation. You may wonder why we're actually showing this as part of our Windows Azure prototype demo. And the reason we are is that we're actually using this as the base for our prototype. So the prototype code that we've built in Windows Azure works by connecting into a running live meeting session, extracting the core live meeting data, being audio, video, and PowerPoint, and then transmitting that data down to a prototype client that we developed specifically as part of this exercise. I'm going to go ahead and open that meeting client, that prototype meeting client now, and you'll see it exposes much of the same functionality. First thing I'll point out is we've got that same audio-video feed. This time, though, it's running not through live meeting, but rather from live meeting through the Windows Azure service and down to our prototype client here. So this is actually running through AV servers and AV code that's right now running in Windows Azure Fabric. Now, we've also implemented PowerPoint presentations. And so if I go back to the live meeting session here and navigate through this slide deck, you'll see that the slides are updated in our prototype client. Once again, this data is all being transmitted through our service running in Windows Azure. So I can flip a slide here. It's reflected in the prototype client. So even over the course of only a few months, we're able to implement a lot of the really core functionality today in live meeting running over Windows Azure. And through that exercise, we've really gotten familiar with it, and we're confident that we'll be able to take this forward and implement a full version of the service in our next generation. With that, I'm going to go ahead and pass back to Mike, who's going to talk more about how this works in the back end.
All right, thanks, John. So let's take a look at the prototype architecture. When we decided to sit down and build on Windows Azure, we had to come up with basic architecture just like for any application. And a couple things to note here is that we have essentially three separate areas. We have a web tier, a real-time tier, and a media tier as part of our architecture. The web tier is pretty much typical of the typical Windows Azure architecture that you've seen throughout the week. So we're not going to focus too much on that. But the real-time and immediate tier have some unique requirements in that they're very sensitive to latency. So being sensitive to latency, the way we address that is we maintain persistent connections between clients and these two tiers. So once we finish the basic architecture, the next phase is to build a service model using the Windows Azure development tools. And this is actually the service model for the prototype that you're seeing, the conferencing service prototype. So what you have on the front end here is you have a bunch of front end servers that are connected directly to the internet. And then we have a bunch of back end roles which serve various functions. So using the prototype that you just saw as an example, I'll walk you through some signal flow so you understand how this works. So if you look on the right, there's a box called the focus, which is in the back end. The focus, in this case, maintains a persistent connection to the live meeting service for a particular meeting. So it communicates with the service and receives messages from the service via that connection. What happens then is the focus has a persistent connection to a front-end server. And remember that a meeting actually exists. There's just one instance of it. It actually lives on that instance of this focus. So it connects to a front-end server, and then a client from the internet is connected, that was John's client, is connected via the focus front end to the meeting. So when John changed the slide in live meeting, a message was sent from live meeting to the focus, and then that message was then forwarded through the focus front end to the client, saying, hey, the slide has changed. The client then, as part of that message, receives a URL to go and actually fetch the slide, which is cached on the front end server. So that's just an example of a slide change and how that happens in this architecture. Key thing to point out here is it is a fairly complex architecture or complex service model, probably as opposed to some of the service models you've seen with Windows Azure this week. So let's talk a little bit about deployment before and after Windows Azure. So in live meeting today, after we finish the development phase, there's a long and arduous process that we go through in order to actually get bits from development into hosting. Once bits are handed off, we go through a phase where we do deployment documentation. The operations team sits down and does capacity planning. If there's, sometimes there might not be new engineering bits. It's just, we have to increase capacity because our usage is going up. So there's a lot of planning, a lot of effort that goes around that. It's all manual today. After that, we go to actual infrastructure deployment, where the operations team will actually deploy hardware that's necessary and other software components on that hardware. From there, we go to the actual service deployment, where if there's bits from engineering, they're deployed into the data center, onto the hardware. And then from there, of course, we go into a maintenance mode where we have a manual operation of monitoring the service for errors, et cetera, and reacting to them. So this process today can take anywhere from days to weeks, depending on the size of a release or the amount of work that needs to be done in the data center. With Azure, we have the same development phase, but we go, once development phase is over, we go into a very simple provisioning phase. You've probably seen examples of this today or this week where you make certain parameter changes for the service via an XML, and then you push a button and you're done. From there, we go into a deployment phase, which is fully automated. Once the bits are delivered, it's a simple matter of pointing to the bits, pressing a button, and the bits are automatically deployed to the new servers or to the hosts. And then we go into another automated phase, which is the maintenance phase, where we have monitoring capabilities in place and reaction to events in an automated fashion. So that whole process, from developing to getting actual code out in the environment and in front of customers, is just a matter of minutes versus days or weeks for live meeting. We actually have, you might be familiar with a Windows security patch that came out recently. And that's a great example. For live meeting, of course, we had to deploy this security patch to all of our servers in live meeting. And that took, from a planning perspective, we knew the patch was coming. And so from a planning perspective to actually getting the patch to all the servers around the world was around a week. It took us about a week to do that. And meanwhile, we've been building this prototype, working on the Windows Azure platform. And we have about 80 machines that are dedicated just to live meeting for this purpose. And those servers were updated actually without us having to do anything. The servers were patched. It didn't affect us. The service never went down. And it was a great thing. Key thing there is that the live meeting team or the team working on this prototype didn't have to do anything about it. The platform took care of all that for us. So let's talk about the Windows Azure Compute Fabric now. So live meeting has some challenges in that we have very uneven usage throughout the day. We have basically between 10 a.m. and 2 p.m. is the peak usage for live meeting each day. And you might have anywhere from a few hundred meetings to several thousand going on at one time. We also have spikes that are caused by large meetings. So we might have a meeting with 5 people, 10 people. We might have a whole bunch of those. And then along comes a meeting where somebody wants to have over 1,000 people in the meeting. Obviously, that takes a lot more CPU, a lot more resources to hold a 1,000-person meeting. So then lastly, what we do is for future growth, we over-provision to account for future growth. We have all these projections. We project usage out. And months in advance, we have to plan for this growth that's coming so that we make sure that we have the hardware in the data center on time and out there. So one of the key aspects, though, is that with our usage patterns also is that during the day, the servers are busy. There's a lot of usage going on. Everybody's holding meetings. But at night, the service is essentially sleeping. We're a global service, but we tend to provision customers and data centers at the parts of the globe where it makes more sense in their time zone. So at night, all the CPU is sitting there not being utilized, yet we're paying for the ping power pipe, everything for these servers. So with Windows Azure, idle resources, when they're not being used, can be returned to the fabric. And when they're returned to the fabric, we're not paying for it, which is a great thing. And in turn, when we have requirements for added resources, for a large meeting comes in, for example, usage starts to increase throughout the day, resources can automatically be allocated from the fabric to us to meet that need. Essentially, what we end up with is just-in-time provisioning, which is a great thing to help us with managing our usage and our performance. So lastly, failures in live meetings today require a lot of manual intervention. If a server goes down, somebody in the operations team, they'll get an alert, then they manually go and they'll investigate the server. And they will either reboot the server, or if necessary, we have to replace the server. That's actually something that we have to coordinate and is done from our team. With Windows Azure, if there's a failure on the server, we could take that server out of rotation, bring a new one into rotation, and within a matter of minutes, we're back up and we're back up the full capacity that we need to be at. So now John is going to give us a demo, actually, of our dynamic scale and failover for our service in Windows Azure. Here, F.
Okay. Yes. Thanks, Mike. All right, so we're going to take a bit of a different view of our service prototype now and look specifically at the back end of the service as it's running today. And we're going to do that through what you're seeing here, which is a monitoring console that we developed as part of our exploration, as also actually for the purpose of this demo. One interesting thing about this dashboard is it's actually running on a utility server in the Windows Azure data center. So right now I'm term servered into a box there. And it uses the Windows Azure Fabric client APIs to get the current running state of this service as it's deployed. You can see that we've designed the dashboard here to reflect the service model that Mike was referring to earlier. So each blue box here represents a specific role in our service. And we've also got each interconnect, including the various switches that they use to communicate between each other. Each host here actually represents a specific instance that the Windows Azure Fabric has spun up to serve that role. In this case, most of our roles only have one instance spun up, but except for the AV front-end servers. And the reason there are two there is because we're going to be focusing on those for the rest of the demo. Now, I don't think Mike actually mentioned this, but the AV front-end servers are the servers that are actually responsible for streaming out that audio-video feed that you saw and that you can still see in this meeting client. So this meeting client here is actually connected in with a persistent connection to that AV front-end server, and the media data is flowing from the AV conferencing server out to that front-end server and down to the client. So we're going to do two different scenarios here. The first one's a failure scenario. And what I'm going to do is I'm actually going to kill instance A here, which is the one that I'm connected to. I forgot to mention, the numbers here represent the total number of connections, the total number of audio-video streams that are being served out by this server. So right now there's one on this one, the one I'm connected to, and none on the other instance. So I'm going to kill instance A, which will cause it to drop all its connections and tell the Windows Azure Fabric that it's basically in an unhealthy state. When I do that, you'll see two things happen. First, and you'll have to pay close attention to see this, you'll see the attendee console's retry logic kick in. So there'll be a disruption to the audio-video stream. It'll go white for a certain period of time, and then it'll try and reconnect in, and its request will be routed to server B, which is still running, and will be able to serve it the video. The other thing you'll see is that the Windows Azure Fabric will react to the loss of instance A and bring up another server instance into rotation to replace the one that was lost. Okay, so I'm going to go ahead and kill this instance. First thing to look at is down here on the meeting client. You can see that the connection was lost and the video is actually frozen. Back up in the monitoring console, you'll see that the Windows Azure Fabric is already working to bring an additional instance back into rotation to replace the one that was lost. And it came up relatively quickly. Looking back at the meeting console, you can see that it's reconnected successfully, and now we have audio-video streaming again. As you can see, that one connection is now on instance B. So using the Windows Azure Fabric and some simple client retry logic, we were able to handle the complete loss of a server in our service without a major disruption to any of the meetings that were running on this service. Okay. The other major value that the Windows Azure Fabric has to offer for us is its ability to handle scale. And so we really wanted to investigate these capabilities as part of our prototyping. Sorry. To do this, we developed a set of bots to connect into the service just like any other client. They'll basically connect into the audio-video stream, the PowerPoint feed, and everything else. And those bots, interestingly enough, since they need to scale out, we decided to deploy them alongside this service as another Windows Azure service. And so it's actually possible to control those bots from this monitoring dashboard here. So I'm going to go ahead and just add some load on here to bring our service up to a steady state. When I send this message, basically the monitoring dashboard here is contacting the bot system and causing it to start to connect into the AV front-end servers. And as it is, you can see, let me get this out of the way so it doesn't distract you. As it is, you can see the number of connections growing on the AV front-end servers. So at this point, we actually have one real meeting client and 600 bots all streaming audio and video off of these two instances. Now, this might be the average steady-state load for our service on any particular day, but we support meetings up to 1,250. And so we never really know when those might be coming in. And so it's not uncommon to see major jumps as a 1,250-person meeting, for instance, just comes in. In the case of live meeting today, we have to basically provision out each tier to handle those spikes. But with Windows Azure's dynamic capacity management, we can actually rely on the fabric to deal with it automatically. So what I'm going to do is I'm going to simulate an additional 400-person meeting coming into this service. And what you'll see is as the number of connections climb, each one will climb to about 500, 1 in 500. Now, the overall capacity of each of these boxes is 1,000. And so when we get to 501 and 500, we've actually reached half of the overall capacity. Now, that doesn't seem like the point when you'd want to scale out. But the fact of the matter is that we have to have enough capacity so any of these could fail and still do that failover trick that you just saw a second ago. So once we get to 1,001 total connections, we need to bring up an additional server. And what you'll see is that our service will work with the Windows Azure Fabric to do that automatically without any interaction of ourselves. So let's go ahead and add this load. You'll see the load count start to grow. And as instance B hits 501, it'll actually go into a yellow state. And as it does, our monitoring dashboard works with the Windows Azure Fabric and quickly brings another server into rotation. It's still activating. Now, it wouldn't come up quickly enough to necessarily handle this meeting, but now that I have additional servers in rotation, I can handle, another 300, even probably handle 1,000 more connections on this service. So you'll see the additional 300 connections are going to come in, and they'll be evenly distributed across the 3 servers that we have here. So you can see that, without much effort on our part, Windows Azure Fabric will handle both the dynamic scaling out of our service as well as the ability to deal with failures. And it'll make sure that we always have enough capacity to meet our load demands. There's 2 things I should note. One thing is that in order to make this a demoable scenario, we had to kind of warm up these instances that were brought into rotation. We did some of the steps in advance about getting our software on them. That's why it was able to happen so fast. By the time we ship on Windows Azure, we expect these scenarios to take 3 to 5 minutes by the time a failure is detected or you need more load before they go into service. Either way, it's still automatic and will allow us to deal with these scenarios. The other thing I want to mention is you may be wondering why the load is unevenly distributed across these 3 servers. You're wondering that? Okay. What's interesting about live meeting is that we hold persistent connections. So these are persistent audio-video connections that are being streamed across. And they tend to be long-lasting. In fact, they almost all tend to last an hour, which is the usual length of a meeting. And so in our case, these connections are being held and not being redistributed evenly across these 3 servers. In the case of a web application where you have much shorter sessions, you would almost immediately see the load even out across them. In the case of us here in live meeting, at the end of the hour, when meetings tend to turn over, you would see these connections be dropped. You'd see a reconnect happening, and at that point, the load would be even. The important thing to note is that it doesn't really matter for us. And each one of these servers is safe up to 1,000 connections. And so, basically, we can maintain this uneven load and not impact anybody. And we actually have logic in place that when any one of these servers goes to 1,000, it'll stop accepting connections. And so all the connections that are on it will continue to run. New connections will be set off to the other servers that have additional capacity. Okay. With that, I'm going to hand it back to Mike, who's going to talk about Windows Azure storage.
All right. Thanks, John. So let's talk about storage. So live meeting, again, has some challenges associated with it. Because of our scale requirements, we have implemented some custom partitioning in order to deal with that. And this takes a lot of development resources, obviously, and operational. But with Windows Azure, we have automatic partitioning and unlimited scale. There's also infrastructure costs associated with our storage in live meeting today. We have SANs, we have SQL clusters, file servers, and all of these things take expertise, special expertise, to have on hand, both in engineering and in the operations team. But Windows Azure isolates us from the complexities of the storage infrastructure. And by doing that, essentially alleviates the need for us having to have all of this additional expertise and spend time and resources actually in developing and maintaining these systems. So when we set out to design the data model for Windows Azure, we started with a traditional normalized schema, just like we have today in live meeting service. For most of the SQL developers out there, this is probably what you would start out with as well. But after talking to the Windows Azure storage team, we redesigned our model to actually be denormalized. So what this typically means is that you take a number of different tables from your normalized schema and you kind of squish it all together into one big table. We modeled our application scenarios with the denormalized schema. We were a little worried, about whether or not the queries we would be able to generate the right queries that we would require for our service. What we found out was that it's actually not an issue. We can do the queries no problem. And of course, the Windows Azure storage is much better for distributed storage at scale, in the sense that what we could do is offload a lot of since we're not doing a lot of joins, as you would with multiple tables and on SQL, you can offload a lot of the compute off to the mid tiers and the front ends. So you have much better distribution of your storage system. So here's a couple examples of different data modeling methods. On your left, you see your typical relational tables like you would have in SQL Server. You have conference ID, you have track IDs, and conference table, a track table, and a session table. This is the types of information that we would need in live meeting. On your right, you can see how we designed the Windows Azure table, which is just one big table, to handle this instead. And you can see you have the same information. You have a conference ID, a track ID, and a session ID. So, for example, in conference, you can see in conference there's a PDC conference. There's a track called cloud computing, and then there's a session that's a live meeting session as part of that track. So, some key things to note here are that there's different data modeling methods that you can use, and for your application you'll have to choose which one, whether you stick with SQL type data model, or you go with the Windows Azure storage model. And for live meeting, what we found is that the table actually works well for us. Also, last thing to point out is you'll notice there's the null cells in the table. Since Windows Azure Storage supports sparse tables, these null cells actually don't take any space on disk at all. So it's actually squished together. It doesn't take any more space than a typical schema does. So now John's going to show a demo of some storage prototypes that we built, that utilize the Windows Azure storage system.
Thanks, Mike. So the last piece of prototype I'm going to show you is a prototype conference manager application. This is essentially the analog to the live meeting manager that we have today. It's a web application that allows you to create, schedule, and otherwise manage conferences on our prototype service. And the main reason we developed this application was to make sure that we were getting a good idea of what Windows Azure Storage had to offer. Now, first thing I'm going to do is log in here, and when I do that, what you're going to see is a list of the conferences, or actually the sessions, that I've scheduled up to this point on this service. And this is actually a query of that same sessions table that Mike was referring to in Windows Azure Storage. Okay, so I've logged in. You can see that this list here is queried directly out of that, that sessions table. Right now I have 2. I'm going to go ahead and create a third one. Come on. I didn't think the web page would be the one that would have bandwidth issues. There we go. Okay. So I will quickly put in some information here. Just specify the title, a description. We'll do a start time and end time. One thing that I'll point out, which will be important later, is that when I create this, it's also possible for me to specify the organizer associated with the specific session. I'm not going to talk about that yet, but you'll see where it comes in later. So when I go ahead and hit save on this, we're going to be doing an insert into the sessions table running in Windows Azure Storage, and it's going to take me back to that same list page. But this time, you'll see that we've updated with the third event. There we go. So there were 2, now there are 3. Now, I didn't get a lot of time to edit or put in a lot of information in that last session, so I'm going to drill into one that I created beforehand, actually this session. What happens when I drill in is it takes me to a conference portal. This is something that you might be familiar with if you use the live registration system in Live Meeting Today. It's essentially a place where you can go to interact with the attendees or the presenters before and after a specific session. Very similar to what we have today, at Microsoft or MicrosoftPDC.com, where you can do registration and that kind of thing. And I've created this event portal based on this session. So you can see we're pulling the session information, the date and time, and the description, once again, all from that session table. I mentioned earlier that when you create a session, you can also specify the organizer. And by doing that, I actually was able to specify it as myself. And that causes this page to pull presenter bio information from my user profile, which is another table that we have in Windows Azure Storage, and display it here. So you can see there's just my name, a presenter bio, and also my picture. So let me go ahead and edit the title of this. They've changed it on us about 5 different times, but I've always thought it could use some snazzing up. There we go. Let's say Cloud Computing Platform Rules. Okay. So when I click Update here, this is actually doing an update into that session table in Windows Azure Tables. And when I go out of exit mode, you'll see that we've once again queried the data out of Windows Azure Tables, and we get the updated title. So far we've talked quite a bit about structured storage and some of the things that we did to access it and use it in the Conference Manager. But blob storage and unstructured storage is also very critical for live meeting. We store a ton of data. Meeting content, videos, which you can upload as part of meetings, and recordings consume a huge amount of data and space in live meeting today. And we need to be able to migrate that forward to our new technology. And so we wanted to make sure that we were well aware of what Windows Azure blobs had to offer. So we've actually implemented view recording scenario in this prototype. And what this will do is when I click on this link, a recording will launch. And this recording is a WMV stored in Windows Azure blobs. It'll be streamed out through streaming servers deployed in the Windows Azure fabric and down to my client here.
Shoe Circus, quality shoes at discount prices. Why pay more? Bill Gates.
All right, I won't make you watch the whole thing. I actually didn't like this ad at first, but I've watched it about 50 times as a result of preparing for this demo. And it gets better each time, so I'd encourage you to keep watching it if you didn't think it was funny the first time. Okay, so as you can see, we put both the structured and the unstructured data storage capabilities of Windows Azure through some of their paces as part of this prototyping effort. And the end result was that we found that it's going to be suitable and very helpful for us as we develop our next generation service. And we're really looking forward to taking advantage of it. With that, I will hand it back to Mike, who will wrap up today's session.
Oh, all right. Thanks, John. So, takeaways from today's session. Windows Azure enables live meetings to take a revolutionary step forward in service fundamentals. It allows us to focus on delivering customer value instead of building all the service infrastructure. And using the advanced features of Windows Azure, you can build an enterprise-class service such as live meeting. So thanks a lot for coming today. Appreciate it. And here's the typical evals and recordings where you can go find this information. I appreciate you fill it out. And we have about 5 minutes for questions, if anybody has any questions. Okay.
Thank you very much. It's nice to see that we can build great applications on top of Windows Azure. And I was wondering how much you have to customize the standard Windows Azure experience we can have from the CTP for the pre-release that is available today. Did you use only worker and web roles, or did you have to implement complementary roles that are not available today?
Yeah, so we did use some facilities that aren't available in the CTP today, but the things that we are using are going to be available in future releases of Windows Azure. So there is some stuff that we've done. The Windows Azure team worked with us to enable this scenario, but it is coming.
Let me elaborate on that a little bit. So we were able to build our own service model. So the one that you've seen, the one that's available today, is can't hear me? Okay. Was just a service model that is basically preset. We were able to define our own service model with our own rules and our own interconnects using the various switches that they have to offer.
Right. Then this means that you're not limited to HTTP and HTTPS incoming requests.
Correct.
That's right. We use TCP. We're also using native code. So I mentioned we're using streaming servers. Those are running in native code. We're using streaming blob, which is another feature that they mentioned was not available yet, but will be in the future. So really the point is that we're taking advantage of a lot of features that aren't available, but it's all part of the future of the Windows Azure platform.
And did you try to work with outgoing requests from a worker role? Did you have to work with it? Because on the schema, there was only incoming request, no outgoing request.
We did actually have outgoing requests. I mentioned that the backend servers actually connect into the live meeting session to extract the data. And so those are doing outgoing TCP. I think we're using RTP, UDP. So we've got quite a few very complex set of outgoing connections that are making that happen.
Okay. All right. I was also wondering about the tooling. You showed a beautiful model about the overall infrastructure. Mm-hmm. Was it built out of a DSL in Visual Studio? Or? Because there are similar pictures we get from one presentation to another. There seems to be a tool there.
Right, that was done using Visual Studio, using DSL.
Okay.
Right.
Yeah.
It comes with the SDK, or is it internal?
That was internal.
It's internal.
Okay.
They do offer a monitoring console. It's just not quite as graphical and pretty as the one we put up. So.
And last question was concerning the STS for identity.
Yes.
Is it a .NET specific one, or do you plan to use in the longer term the .NET services we provide?
It's custom is what we're using now. In the long term, though, we do plan on using either live services or .NET services.
Okay. This is a great experience. Thank you.
All right.
Thank you.
Thank you.
Very quick question. When you were spinning up new server instances to handle load, first thing I thought was, how are you going to get those things to spin down again, considering your persistent connection capabilities and the fact that every minute is costing you with the cloud services people. So maybe you can just comment on how you pull back.
It's actually an interesting question, and one that we haven't fully gotten into. But I think what will eventually happen, I mentioned that we have the capability to tell our servers to stop accepting connections at a certain point, particularly at 1,000. And so what we'd probably look to do, this is a
drain.
Yeah.
Drain. What we'd probably do is drain. We would tell the server to stop accepting connections, let the server drain, and then we could take it out of rotation if we had to. at that point. But even if, even after we let it drain for an hour, 2 hours, whatever, and it still didn't drain, I mean, you saw the failover. What we could do is just actually take that instance out of rotation. Some people will get a momentary glitch, but they'll be up and running again in a matter of seconds, as long as that other role there's another role standing by to take its place. So.
You may have answered this earlier, but some of the streaming and relay services for the video, is that available currently in the CTP of Azure?
Oh, no.
Not at all?
That's our custom code running
Okay.
in the service.
And is that something that will come eventually, the ability to relay information like that as opposed to having a cache or a storage?
So our service will have an excellent set of APIs that you could consume.
Okay.
We're not ready to talk about them now.
Okay.
But we will, and I don't believe that it's part of the overall roadmap to offer that kind of functionality directly as a platform that's not part of our specific product.
Got you. But you're thinking live meeting in the future would offer some of those?
Yeah, absolutely. I mean, we have the XML APIs today. I think in our future iterations, we'll be expanding that considerably to support some more of those types of scenarios.
Great. I have a question about storage. I wonder if in your previous or in your existing application you used transactions at all and how you dealt with the lack of transactions in this storage model.
Yes. So we did use transactions heavily, as you would imagine. And so one of the things that we found is that there's some transactions you just can't live with. I mean, you just can't have them. But if you do want to have transactional integrity, it'd be nice to actually bring back the table.
Yep.
You can take our sparse table model and ensure that, for instance, if you wanted to do a transactional insert on a specific session, conference, and thing, because they're all in the same table and because they're within the same row group, you can actually do a transactional or an atomic insert or modification of those. And so if you can pick and choose which things are most important to have transactions and support them in a limited way.
We lost you. Did you hear you? Did you hear the answer?
I think so. So you're saying that if you model your data so that all your transactions fit within a row group, you get a transaction by default?
You can, yes, that's right.
Any more questions? All right, does anybody in the room have one of those blue bands, light blue band? You do?
He asked a question.
He asked the question, you win.